Hello. Okay, so as promised, section 6.3. Hopefully this isn't too long. We got 3 pages to get through. Matrix operations. The beginning, I think you'll feel, okay, the add, subtract, multiply by a scalar. I think you'll agree, pretty easy, pretty intuitive. Multiplying matrices is a little bit like rubbing your stomach and hitting your head, or patting your head rather, okay, at the same time. Multiplying matrices by hand is weird, but I'm here to get you through it. And then also I'll show you how to do these things in the calculator as well. Then identify equivalent matrices, solve matrix equations, and evolving, subtracting, addition, subtraction, all that good stuff. So where to begin? Okay, yeah, so definitions. Equivalent matrices, two matrices A and B are equivalent. A equals B if A and B are the same size matrix and all corresponding elements are equivalent. So it's pretty much what it sounds like. So if this, let's just for sake of argument, say here's our matrix A. If A equals B, then B really would be a copy paste scenario of A. Easy peasy lemon squeezy, hopefully. So now just some recap info of what we talked about earlier in 6162. Remember when it says what's the order of A? It also means size. So it's important that you know that. Remember, it's row by column. So this is a 2 by 3 because there are 2 rows and 3 columns. Remember, rows are horizontal, columns are vertical. Identify element A23 and A12. I want you to pause the video real quick and see if you can do it. But my hint is, remember that I want you to think of it as like A2, 3 and A12. Okay, pause the video, come back. Perfect. Okay, so let's see. A2, 3. Remember, this is the element in row 2, column 3. So that's just -1/5. So element A12, remember, I don't say element like sub 12, but it's row 1, column 2. So that is 2. So nice refresher there. Then if we want to add and subtract matrices, it's pretty, I'm gonna go with intuitive. I think it's what your gut instinct might tell you to do, but yeah, I know you'll tell me if that's wrong. So it's where each respective position, element is added or respectively subtracted. So if I'm looking at example 2, if we're adding these 2 equations together, or 2 matrices together, pardon me, it's literally just top left, those get added together. Then you just respectively, like if you want to move to the right, those 2 get added together, then these 2, and then so on and so forth. So we would have, 0 minus 2, 5 plus 3, 3 plus 5. You don't have to do this. I'm just being a bit extra, throwing emphasis on exactly what is done here. So then what? Let's see if I can math without y'all in front of me. Bear with me. So 5 plus 3 is 8, 3 plus 5 also 8, -2 plus 7 is 5, 6 minus 9 is -3, and then -2. Ta-da! Oh man, y'all are gonna have to take it on faith that I know what I'm doing here. Or I can mental math, which y'all have seen that happen before. So with subtraction, same thing. The only difference is that here you're going to want to distribute that negative through to the other term. So generally, especially when learning, I just like to go ahead and do that. So it's really just plus, negative times a -5 is +5, and then -6. 0 doesn't have a sign connotation, and then so +4. And now it's just like above. So -6 plus 5 is -1. 7 minus 6 is +1. 2 plus 0 is a 2. -3 plus 4 is 1. Perfect. Okay, hopefully y'all agree. Easy peasy, right? Not lemon juice squirted to the eye. That might be the multiplication. Just kidding. Maybe not. You'll see. I want you to form your own opinion. But multiplication, not scalar multiplication. This is very much so like we just did for B. It's like distributing. But first, let me give you the formal definition straight from your book. So just kind of jot it down, pause to catch up the writing. And then when you're back, I will just explain what the heck this actually means. So if matrix A, which has elements A, J, is a matrix of order m by n, and C is a scalar, then the matrix CA, so that's C times matrix A, is the m by n matrix given by C times matrix A equals C times every element in the matrix AJ. So just like I did above with example B, distributing that -1, right? Technically -1 got distributed to everything. You're going to do that for scalar multiplication. So whatever this number is, right? C, you can think C coefficient if you would. It's actually constant scalar. But it would just get distributed to every element in that matrix is really what that says. All right, so this matrix is obtained by multiplying each element of A by the real number. All right, so I kind of lied to you. I did the explaining as I wrote. But so just to recap, yeah, you're basically just distributing whatever this number is throughout every element into the matrix. That's it. So let's practice with it. So assume we've got these two given matrices, A and B. These are what size? Hopefully you said 2 by 2s, right? 2 rows, 2 columns. These are 2 by 2s. You'll find out in 6.4, that's what we call a square matrix, but you can figure out why. Yeah, it looks like a square, right? It has the same amount of rows as it does columns. Square matrices. Didn't get too crazy when we labeled these things. Okay, anywho. So if I want to know what -5b is, what do you think we do? Hopefully you said take b and multiply or distribute, so to speak, a -5 to every element. And you'd be correct. So pause the video. I want you to give it a go. And then once you've taken a whack at it, press play. Okay, so then we've got -5 times 2 is -10. -5 times -3 is +15. And then what? -25 and +30? Nice. Okay, we're going to keep going. So here, just comboing, you know, how we like to just ease our way into the deep end of the pool, so to speak. So 2 times A plus 3B. So I am looking at 2 and I'm going to multiply, I'm looking at A, and I'm going to multiply a 2 to everything. So -2, 8, 6, 0. And then we're going to add it to 3B. So 2 times 3 is 6, -9, 15, and -18. Then we just, do what it says. So pause the video, give it a whirl. Okay. So let's see, 6 minus 2 is 4. 8 minus 9, -1. 6 and 15 is, let's see if I can math. What is that? 21. Why can't I math right now? Yeah. Sorry. And then negative 18. Oh, that should be a negative. Oh, wait, here, my like 3 times, right? Yeah, sorry. Y'all know what happens when I try to do stuff in my brain. Y'all catch me all the time. I need you. Keep me honest. Okay, so that's addition, subtraction, and scalar multiplication. So next video will be solving matrices. Oh wait, hang on. That doesn't sound right. Yeah, solving matrix equations. Perfect. Okay, next video.